What is machine learning? So machine learning is a branch of artificial intelligence concerned the construction and study of systems that can learn from data itself. So it is something the designing of the algorithm. Be clear at this time that we are not talking about how to design those machine learning concepts, right? That need, you should have a very good mathematical skills, very good statistical and very good programming skills. But today in this class we'll try to use the existing algorithm like clustering and how those clustering help us in taking decision. So that's a difference here. The emphasis of machine learning is on automatic methods. In other words, the goal is to devise learning algorithm that do the learning automatically without human intervention or assistance. Some examples of machine learning problem: medical diagnosis, diagnose a patient as a sufferer or non-sufferer of some disease. Like in even in my company, we are working on this model for a long time, based on some diagnostic code, because in America every diagnostic condition has a particular code associated with it. So based on the diagnostic code, can we predict that this particular disease, the patient can be suffer from this particular disease, let's say AIDS or cancer or anything, or a non-sufferer. So based on that, based on the data, we try to come up with that, and that would help us in finding out or locate the fraudulent activities if anything is happening there. The next example is customer segmentation. Predict, for instance, which customer respond to a particular promotion. Promotion in the way, like you must have seen these days, every company is promoting their product through different ways, and for different customers they have different promotion schemes, and the different customer, they tap through the phone number like SMS, or by their website, by their email address or something like that. So in this way, first they do not send. Let's say a company having a customer base of 2 million or 2 billion. So it's not that they would send the promotion offer to everybody. Even what they do, they try to make the cluster of their customers based on different characteristics like spending habit, earning potential, or salary, or the taste, or religion, or something else. Then they would try to tap each customer or the cluster in the different customers in different way, and they try to promote, they try to improve their profit. Fraud detection: identified credit card transaction, for instance, which may be fraudulent in nature. Weather prediction: predict, for instance, whether or not it will rain tomorrow, something like that. We'll take the today's case study on this weather data set. We'll try to understand the cluster analysis on this weather data set that is already available in R. Machine learning is a class of algorithm which is data driven. Unlike normal algorithm, it is the data that tells what good answer is. So machine learning is an algorithm as well, but they try to, using clustering or unsupervised and unsupervised learning mechanism, they try to learn and give you the output based on that. Efficiency depends on so many factors that while we use machine learning, we need to be very careful. Like I always talk you that before developing a model, what we do, we actually do the data analysis, the outlier analysis, normalization of the data kind of thing. That is the first first step towards machine learning concept or any statistical model building. For example, a hypothetical non-machine learning algorithm for face recognition in image would try to define what a face is, like round, skin-like color, dark area, where you expect the eyes, etc., based on the previous or the past data of faces. A machine algorithm would not have such coded definition, but will learn by example. You will show several images of faces and not faces, and a good algorithm will eventually learn and be able to predict whether or not an unseen image is a face. And if the algorithm is very good, it even can, detect the faces. Like in this example, we talk about that whether a particular image is a face or some other image of some other object, like fruits or vegetables or anything. But a more better algorithm even can detect that face is between the different humans, like human faces can select that this is the image of Mr. Mr. X that in the data. So type of learning, there are two types of learning, supervised and unsupervised. Supervised is something where there are some initial points through which it can understand, the algorithm can understand. Like regression is a supervised learning mechanism. Unsupervised, it would be more clear like supervised and unsupervised when we move on with different statistical concept. Today we are discussing clustering. Clustering is a unsupervised learning. Regression is a supervised learning. So as soon as we move on with different examples, different statistical concept, it would be more clear to you. But for understanding, take this example that regression is a supervised learning and clustering is a unsupervised learning. Why? I will tell you when we talk about the development of the model. Supervised learning. Training data include both the input and the desired result. For some example, the correct result targets are known and are given an input in the model during the learning process. So we know that in this supervised learning, what the target is, what it needs to be predicted. Like I told you, in credit card fraudulent activities, the target is to get the probability, that what we understand as CIBIL score in India. So CIBIL score is basically the probability, but it converts into the score. The probability of being default. So that is the target variable, and the other explanatory variable are maybe the salary, maybe the number of other credit cards the person has, whether it's what is his gender, what is his age. So there are different attributes, maybe 30 or 40, so which they try to figure out that what is the probability of being default or non-default. So that is the target variable. So supervised learning mechanism use the target variable. The construction of proper training, validation and test set is crucial. These methods are usually fast and accurate. Have to be able to generalize, give the correct result when new data are given in input without knowing a prior the target. Now, as we know that, or it's written that these methods, like supervised method, are usually fast and accurate. Then why we use unsupervised method? I think it's a big question. If supervised method are itself are very fast and accurate, and they are, then what is the need of using unsupervised method? Can anybody tell me why we are learning those? Because we know, mathematical point of view, if one algorithm we have and it is working fine, then we do not use, or we do not have the same kind of algorithm or same kind of mathematical explanation. Anybody? Abhinay is saying the data set changes. Yes, Abhinay, you are right. And like supervised methods are usually fast and accurate, and they are. But the problem is that we sometimes come across a situation where we do not about the target variable. We do not know anything about the data. Like the Abhinay is saying the data characteristics. I'm putting that into my word. You're right, Abhinay. So in that case, where we do not know about the target, or we have a little knowledge on the data, then we have to have some other way where the supervised learning methods cannot work. So under those situations, we use unsupervised learning. Although supervised methods are faster and accurate, but as we have no choice because we do not know about the target variable, So we have to use the unsupervised method. So they are very crucial and very useful in their own terms. And as they are less accurate, that's why the fight between understanding and implementation, and choose which particular algorithm or which particular methodology to choose in case of the unsupervised learning method. Okay, what is there? So look at that. It is the supervised learning. Like it has been shows the image of two elephants of different size, and then it's been asked with the image of elephant that whether it's an elephant or not. The supervised learning is something like that. So we are training, and then it can predict, it can give you the correct answer. So this is the supervised learning. It's something, a flow diagram that what we do with the data when we use the supervised learning methods. So we have a data, we try to convert the data into test data and training data and validation data. In that way, we divide the data into two parts. Let's say 70-30 or 60-40 or 65-35, whatever. So we divide our own data into two parts. One is for training and one is for validation. Training data will use to train the learning method before applying supervised. Yes, Abhinya, yes, before applying supervised method. So we have our training data. Let's say we have the weather data set and it has around 10,000 rows. So what we try to do, first we'll try to partition it. And then if we are about to use the supervised learning, and the decision that we are going to use supervised or unsupervised depends on our objective, depends on what we want to achieve. Then only we can move on with supervised or unsupervised. Like it depends what is our objective is, what we want to achieve. Based on that, we will decide that whether it will be an existing supervised learning method or unsupervised learning method, right? So 70-30 in this way, training data set, we try to apply the concept, machine learning. On the basis of that, we'll try to develop the model. That model, the same model, will test those model on the remaining data set, like 70% of rows. In our example, 3,000 rows. We'll try to use that model on those 3,000 rows, and then we'll check the accuracy. Based on that accuracy, can we improve our model or not? We'll look at that. Otherwise, we'll move on the final phase and use it for predictive modeling for new data set or new homogeneous data set. Okay, so that is something what we do in supervised learning method. Sorry. And how we predict? Now we have a statistical model with it, which we developed on the training data set, and we check that model. We test that model on the test data set. Now we have a statistical model with us, and we'll try to predict with new data set, apply that statistical model, and predict the outcome. That is what is happening on the credit card score or CIBIL score that we know. They developed that model on the, let's say, 10,000 or 1 lakh credit card customers. They develop that, they test on the existing customers, and now as I'm a new customer and I want I want a loan, home loan, then the bank would look at my credit score. So what is that? The credit score is something. They are using their statistical model, the credit algorithm model, on my data with different data variables, and try to predict that whether I would be able to pay back my debt or not. What is the probability of paying back? It's something like that. That is what happening in the real scenario. Okay. Unsupervised, this model is not provided with the correct result during the training. Okay, but I told you, if we do not about the target, we do not have any knowledge of the data, and sometimes we even do not have any objective. Okay, so in that case we use this unsupervised learning method. Can be used to cluster the input data in a classes on the basis of their statistical properties. Only cluster significance and labeling. The labeling can be carried out even if the labels are only available for a small number of objects representative of the desired class. So we'll discuss that. It's not that the cluster. Abhinay has a question. Both new data and old data must be similar. Is there any way to see both data as similar? Similarity in terms of, yes, Abhinay. The both new data and old data is similar means that you have a credit score data with you. Okay, so it has n number of rows and let's say 40 columns. So new data has the entry into those 40 columns, right? So new data means only the row value is changed, row entity is changed, column entity is intact. I mean, it has all the 40 variables there. You got my point? Like the table structure in SQL, we enter a new row, so that is a new data. Okay, the data should be homogeneous, definitely. Okay, unsupervised, the model is not provided with the correct result during the training, can be used to cluster the input. So let's discuss that. Unsupervised. Okay, look at that. The machine or the robot, we give a pot of containing different fruits, and now it tried to put that into different clusters. They are different, basically example of clustering. So it tried to cluster into different groups. Like apples are distinct because apple itself has distinct characteristics, similar characteristics, but distinct with grapes. Similarly, distinct with banana is distinct with oranges. So based on those characteristics within the data, it tried to put apart the data. So that is what unsupervised learning. Right? You remember, like in the previous example, it has been shown the shape of the elephants, and then it tried to ask that whether it's a new face or new image as an elephant or a lion, something like that. In this way, we have historical data, we apply the machine algorithm, and based on that we will have the rules and patterns. There are certain ways to look at those patterns, and to figure out whether this pattern is working fine or not. But it depends more of your domain knowledge, because these algorithms do not give you an accurate result. So you cannot rely on the outcome of the algorithm itself. You need to apply your business logic. You need to apply your statistical knowledge, right? Your domain knowledge. Then only you can, figure out that which model is working very fine, because you do not have a training data set or test data set with you. Okay, so we'll apply the machine learning, we'll have the rules and pattern, and then we'll try to use the same rules and patterns on the new data and try to predict. So that is what unsupervised learning. So we'll have one unsupervised learning session in today's class, right? Difference between supervised and unsupervised learning. The example of face recognition is supervised, which means that your example must be labeled or explicitly say which ones are faces and which ones are not. In an unsupervised algorithm, your example are not labeled. You do not say anything. Of course, in such a case, the algorithm itself cannot invent what a face is, but it could be able to cluster the data in different classes. It could be able to distinguish that faces are very different from legs, which are very different from horses, right? You got that? Our brain does all these things on itself. Brain is a wonderful organ. It uses supervised and unsupervised learning methods. Supervised in what way? When everybody of us started learning the bicycle in our initial days, like when we first started learning any vehicle, the bicycle was the first thing. So where there our fathers or elder ones used to tell us that how to pedal, or what things are need to be taken care of. But did they tell you everything about any situation would happen in real life when you actually drive the bicycle in real life? No, it's not possible. But our brain itself learned from the examples and it took decision. Like imagine in a rainy day, you are driving your bicycle and suddenly a car comes. You simply tilted your bike and you move on, and you are listening your song. You have a on mobile or something else, but you don't care. Your brain took all those decisions and do it. So brain is using all these techniques, supervised and unsupervised. Basically, this artificial intelligence concept is taken from the way the neural networks works in the brain. So that's a very good distinction between supervised and unsupervised. It uses training data, no training data, apply model to test data. Model, inference, and application both rely on test data exclusively. Supervised, logistic, linear, decision tree, random forest are supervised method. What is decision, random, logistic, linear? We'll discuss later. Unsupervised, k-means clustering is a unsupervised method. How it is unsupervised, I will tell you. Supervised learning example is one bag with apples, one mixed bag, and it has to build the matter like the recent example, right?